So now that we know how to visualize the spatial mapping mesh, we're going to learn how to process that mesh. Processing can help improve performance and visualization. There are several techniques available, including hole filling, smoothing, plane finding, and vertice removal. In this chapter, we are going to be using plane finding for transforming our spatial mapping data into planes. We'll learn how to classify those planes as floors, tables, walls, or ceilings, and then use those surfaces for placing our holographic science fair posters and the solar system in our world. So at this point in our app, we're able to visualize the spatial mapping data, but we're using a lot of triangles just to render blue lines on the walls. So if we were to do some processing on the mesh, we might be able to get some simpler objects such as planes, which would be a better representation of floors and walls. Now to help us with some processing, let's add another prefab. So go on down to the holograms folder and locate the spatial processing object, drag and drop that into the hierarchy. Now this object will have added 3 different components. We have our Play Space Manager, which is application-specific code for interacting with our spatial mapping data. What it will do is it will limit our scanning time to just the initial part of the experience. So the first 10 seconds that you're running the application, you will be in scanning mode, and you'll see that wireframe, which is going to be the default material. After 10 seconds are up, we're going to kick off processing, and for that we will be using plane finding. Once we've found our planes, we can switch to our secondary material. Right now we're just saying wireframe, so you won't see an actual change. And then we're going to analyze if we have floors and walls in order to place objects on. The other component on this object is the surface meshes to planes. And this is the piece of code that we'll be calling our plane finding DLL from the Holo Toolkit. Now this plane finding DLL is actually the same DLL that's used by RoboRaid for finding planes, and it has the options of determining which planes that you want to find, such as walls, floors, or ceilings, and which planes that you want to keep around. So you can go ahead and find all planes except tables. And if you wanted to destroy tables, you could use the destroy planes option to select tables and then use the actual spatial mapping mesh instead of planes in order to represent tables. Play Space Manager will also call our remove vertices later on so that you'll be able to remove any of the spatial mapping points that fall inside of our planes. But let's take a look at surface meshes to planes. Just double click it to open it in Visual Studio. And let's navigate down to the Make Planes routine. So in Make Planes, we're going to call Make Planes routine as a coroutine. So if you're not familiar with Unity, Unity's coroutines, they're a great way to fake multi-threading. So it can break up the work across multiple frames. So if you have a function that needs to be running on the UI layer, such as this one, or on the UI thread, and you don't want to freeze the thread, then you are going to want to break it up into coroutines. Let's just take a brief look to see how we've done that with the Make Planes routine. So once we're in Make Planes, we are going to be calling our plane finding DLL. And from that, we're going to be able to just send all of the mesh data that we gathered from our spatial mapping manager. So it has all of the meshes that we need. And we're going to send them to this plane finding DLL. And it's going to send us back some bounded plane objects. And once we have all of those objects, we can go through them and decide which ones are floors, which ones are ceilings. So once we have our bounded plane array, which is filled with planes, we're going to find which of those planes is the largest plane that has a normal pointing up. And we're going to classify that plane as the floor. So we're going to loop through all of them and determine that. And then we're going to do the same with by testing all of our planes and looking for one that has a normal pointing down and is the largest one with that. And we're going to call that plane the ceiling. And once we have a base floor and a base ceiling, we'll be able to later classify all of our planes using those as a reference. And we're going to be doing that using our surface plane prefab, which is just an object that, or another prefab that knows how to classify our planes. Once we've classified our planes, we can determine if we want our planes to be visible or not. In this case, we're just going to be rendering our wall planes because those are the only ones that we want to have blue lines on. The others we can just turn off. And then if there were any planes that we wanted to destroy, we're going to do that here too. So again, if you wanted to say have round tables, you would go ahead and destroy tables so that you could preserve the round spatial mapping mesh instead of using square planes. So once we're done making planes, we now have surfaces that we can put objects on for our science fair booth. So to make our application more exciting, let's add some holograms to our scene that we can set on the planes that we just found. Go to the holograms folder and select the space collection object. If you expand the component, you'll notice that we added 3 different objects. That includes our projector box, which will have the solar system in it, and 2 posters, rocket poster and astronaut poster. The posters will have an affinity to be on walls, and the projector will be set on floors or tables. Let's switch back to our spatial processing object and then open up the Play Space Manager. At this time, you're going to want to copy and paste the code in from the website, or at least complete all of the to-do sections, the 3A developing coding exercises, and go through that. So if you want to just quickly copy and paste, you can do that now. Paste over Play Space Manager. And what we're doing is we're going to be adding all of the processing steps to our code. So let's save our changes and navigate back up to the top so we can go through what changes we just made. So the first thing we did was we checked to see if our observer was running. And if it was running, still running after 10 seconds, then we went ahead and stopped the observer. And then we're going to call our create planes. And this just in the under, if you look at the function create planes, it just calls our surface meshes to planes. Once planes are complete, we will get an event, make planes complete, and we can go into the handler here and we'll determine which planes, if we have enough planes in order to continue. So we want a collection of both horizontal planes and vertical planes. And we can get our horizontal planes by querying get active planes and asking for the table type and the floor type. And we're also going to want to do the same for our vertical planes, and we'll ask for the wall type. Then we're going to check, do we have enough horizontal planes to continue? In our case, all we really need is just 1 floor and we're happy. And we also need 1 wall, vertical walls, in order to place our posters on. The floor, we're going to be putting our projector box on. After that, we'll go ahead and kick off remove vertices, and this is just going to help simplify our mesh data by removing all of the excess triangles that happen to also lie inside of planes, because we don't need to double represent walls and floors anymore. And then we're going to call set surface material with our secondary material. Now we're not using it just right now at this moment, but we will visit this later in the occlusion chapter. We're going to actually set this to be our occlusion material. Our final step is we're going to be calling generate items in world from the Space Collection Manager. And this will place our projection box on the nearest floor or table surface, and it will place the 2 wall posters on the nearest walls. So we will have the basic building blocks of our science fair booth, and we'll be all set for our next chapter where we can move objects around against the spatial mapping data and the planes that we now have in our project. And just as a final step, we are calling the start observer again in case we did not have enough floors or walls to continue. Now let's just go back into Unity and press the play button to preview. You'll have to wait the 10 seconds as we do have a 10-second scanning, and you'll notice after 10 seconds the mesh has been converted to planes. The wall planes will have blue lines on walls. We have not yet turned off our floor or ceiling. We'll do that at the beginning of the next chapter. But you'll notice that our projector box is in the floor, and we have 2 posters now on the walls. So at this point, you're going to want to go back and say File, Build Settings, and build and deploy as usual, and locate your projection box and your posters in the real world using your HoloLens. All right, so we now know how to use plane finding to simplify our spatial mapping mesh, and we have holograms in our world. In the next chapter, we're going to learn how to move those holograms so that we can place them where they matter most to us and will look best in our science fair booth.